All right. Hey everyone, I'm David Room. Tonight we are going to be doing some more game dev with Python and um I was thinking the other night, it's been a really long time since we've done some 3D modeling with Python. I don't really have new ship designs in mind, but there are a couple of ship designs that I want to revisit. One in particular, which has been kind of stuck in this beta state for a while that I'd like to fix up. So I thought it would be a good excuse to do that. We've been kind of going through and checking a lot of random things off, fixing a lot of random little things uh, in the process of building this space combat game. And might be time to kind of pivot away from some logic back towards making a little bit of content. So let's get started. I'm going to get some white bat audio going. We're going to try some synthwave tonight. So this is their morning mist uh, synthwave playlist. So let's get started. I've got my coffee here. I'm having a good evening, kind of relaxing evening after a long day at work here. And let's get into it. Okay, so what we're looking at today is a particular ship, the what I'm calling right now the this unknown fighter. And a while back I made this spreadsheet of some of the different ship types that I was wanting to create. And at the time, I think I had kind of come up with the design for this ship first and then added it. And what I realized is exactly what this note says, is that this is probably going to be a shuttle, not a fighter. And I don't really have a small civilian ship. Right now I've got containers, I've got some big yachts, I've got freighters, started working on some space docks, space stations. I don't have anything really like a shuttle, and of all of the designs, I think this one is the most shuttle-like. So we're gonna actually make it a shuttle. Maybe fill in some missing things here in our tracking spreadsheet for some other ships too. There's definitely a few pieces missing here, so there's a few things about the design that I want to change, and I want to add drive glow. Actually, materials and livery might be a nice one for this one, because it has a nice spot that we could put some livery on. And yeah, so let's just get into it. I'm gonna kind of relax here. It's been a while since I've looked at some of this modeling stuff, so it might not be the fastest progress tonight, but that's okay. We are relaxing, having fun. Let me just double check the status here. Okay, nice. Yeah, Doug Wise is here. He says, "Yeah, nice change of pace, music, and dev focus." Yeah, I think this will be a nice nice time. So, yeah, let's first of all just take a look at what the ship is now. And another reason that I wanted to work on this is that I'm kind of imagining some maybe different modes in the scenario, like in the simulator, for sort of quick scenarios. And I'm also starting to think now about actual missions, and I think a common actual mission in the game is going to be something like where you are pursuing a civilian craft, and the goal would be to like try to, you know, keep within a certain distance of it for a certain amount of time. And yeah, mostly I've been making these sort of, you know, fighters and capital ships and stuff, and I'm wanting to build a civilian, a small civilian ship, like a shuttle. So that's what this is going to be. So let's take a look at it here. So this is the ship. I like this design a lot. So in my setting, the ships have these sort of magic thrusters and drives that use like a spinning, sort of a spinning interior piece to generate thrust in a non-reactive way. And I always had these sort of small cylindrical things, and then I realized, like, oh, you could have sort of a big cylinder as well, and you could kind of, instead of having thrusters, you could kind of vector with different parts of that bigger ring. So something I'd like to do tonight is add little glowing bits to this ring that we could eventually maybe use to show that sort of thrust vectoring. And then another thing I want to change about this design is instead of having these radiators that are sort of protruding. Actually, let me just let's see here. Actually, let's check the overlay. Let's see here. Screenshot mode toggle. Yeah, so yeah, instead of having these, whoops, translate up should be, yeah, okay. Yeah, so instead of having these protruding radiators, I'm imagining something that is more flush with the back of the ship. And this being a shuttle, having sensors and shields all over the back isn't as important. So what we'll probably do is we'll probably leave the code in that puts those things there. So we could add them back for maybe a kind of weaponized version of this ship at some point. But we don't need them right now. Also, we could swap. These are hard points. Shuttle wouldn't really need hard points, so we could swap the sensors over, and then this top surface, like, we could keep the little shield generator shields here, but we could do something like we could do livery or put a symbol here on the top, or we could even do windows or something. So yeah, let's get into it. I'm gonna make a new entry here in my log. I keep a work log in a Git repo between a couple different computers, but I have personal stuff in there too, so I don't want to accidentally show it on screen, and it's also a little bit out of date. I've been really busy, so I haven't had time to move things back and forth. For a long time, I was using my MacBook, which is what I stream from. I was using that pretty much exclusively, and I've started doing some stuff with my Linux desktop, so my work log has been kind of out of sync between the two. So this is going to be, what day is it today? It's Wednesday, right? Almost Thursday. So first of all, let's just rename a few things, because we're still calling this a fighter when it really shouldn't be. And I've got some fighter name. We're gonna call this shuttle for now. And of course, we'll have an actual more, you know, specific like branded name for it at some point. But for now, let's just get some of this stuff renamed. We'll just call this shuttle, and let's rename this. Let's see if this renamed it properly. Okay. We've got unknown here somewhere. In our templates. Oh, I bet I know what's going on here. Unknown. Yeah. Unknown. Okay, so there it is, and it's not a fighter. It is a shuttle. Maybe let's still just call it let's just call it shuttle for now. That's okay. And let's see. Yeah. Okay. So now we've got to fix these things too. So so we're going to rename this file. So I have one Python file for each ship design that I have. So let's see here, fighter. It's going to be refactor, rename to shuttle. And one nice thing about having all of these things be code is when you have code, you can use an IDE's refactoring tools to rename things and fix things. So we can do that here. We can do this refactor. Yeah, we don't have a high detail version of this. And let's just test this in. So now we've got to just shuttle. Not sure that this actually ran. Yeah. I'm gonna have to do a little bit of debugging here, I think. Simple. Okay. Now we should see in our directory here everything here, and probably there's gonna be a shuttle or a fighter that is, yeah, May 7th, so we can just get rid of this stuff. Now when we run our, it's like this sanity check to make sure I'm not working with outdated stuff. When we run this now, it should fail loading the shuttle, so we have to update this to shuttle. Yep, there it is. Okay. So yeah, now we can work on the updated design. So let's add a little thing to our workbench here. I haven't forgotten how my at least generic stuff and my utilities work, so that's good. Okay, so yeah, here we have our parts, and just a second here before we go on. I have a new part viewing function that I think might be useful. View parts. Oh no, I don't have any random color parts viewers. Must be thinking of something else. Okay, so yeah, we can do this now to test our variations. So let's just I think original design, I had this for some of my models, so we'll just make this flag so we can keep our original design. So reactor. Okay. It's nice to revisit this stuff. It's good to just like refactor things. make things more modular. Okay, let's just make sure it still looks like we expect. Uh-oh. We broke something. Oh, I just commented that out for some reason. Okay, yep, so we still got original radiators. Now, if we go in here and start editing this, right? So if we say if actually we want if original design. So this should make those disappear. Yep, okay, so now basically we just want a different radiator design here. But before we do that, let's tweak some other things here. So we don't need, or we're going to get rid of the sensors and the shields in the back if it's not the new design. So like if original design raise.extend, and that's these ones that are going to come in from the rear. Let's just check this. Yep, we got rid of those shields. Now we're going to do the same thing with the sensors that come in from the rear. So if original design append, it's interesting reviewing this stuff too, because it's been a while since I've wrote this code, and one of the fun things about, you know, having a code base like this and writing it yourself is your tastes change over time, and it's fun to update your code base to reflect your tastes and thoughts about how things should be written. I think now for stuff like Ray, I mean, Ray doesn't even belong to decal anymore, or does it? Let me just... Some of these I thought I had moved actually to be just types in modeling. Polymesh plane. Oh, interesting. Ray isn't one of them. That would be a nice little refactors to just make Ray a be a nice little thing. For now, let's just actually import it. I think it's the only thing I just import that guy directly. I don't like looking at decal.ray. Okay, so now if we look at this, yeah, our back is empty. So let's actually, now we can use the this is the this piece is called the reactor. So we're going to use the outline of the reactor to make and kind of inset it to make two radiators. So let's do that. And let me just actually check something. I don't think parts. Oh, nice. I forgot about this. Let's actually test this because I think I'm gonna want to check the vertex colors when view parts, and we want smooth. Actually, we can do this too. It should be okay. Oh, I took the radiators away now. Now see, this is the fun thing, right? We can just toggle back. So I can just go shuttle.original design equals true. This thing should come back, and we should see a black to white gradient on. Whoop. Okay, so this is, we must have goofed up the extend or append. Extend. Raise.extend. Oh, I think I know what I did. I think I appended. Yeah, I appended a list. Yep, and there we can preview and make sure that we've got the right gradients. And these actually it's hard to see, but there might be a little bit of asymmetry in that gradient. We might want to flip those around. Actually, let me just do that quick, as long as we're messing, so I don't forget. Oh, this is a nice song. I like this one. It's really pretty. Some of White Bat's music is not super pretty. But some of it is. This is a nice one. Okay. Let's see here. The vertex colors are going to be the same because the vertex orders are going to be the same. We're just going to swap the order. So we're going to say rad flip equals mu.mirror x rad. This shouldn't touch, yeah, that doesn't touch the face order. Yeah. Okay, cool. Yeah, and this is nice because then we can double check our shading, our smooth shading too. Okay. Okay. So, otherwise, for the new design, we want to take that reactor rib and yeah, so we're just gonna slice it in half. And I've got a module to do this. I just have to remember what it was. So, let's see here. Slice. Is it in polys? Union. Yeah, split poly. Okay. Right. Okay, so let's just reactor, reactor 2D, and this should be actually that's already should already be 2D. So mu dot loop see split. Okay, switch.polygon. Just use that constructor directly. And what we're gonna do, since we know it's gonna be symmetrical, we will split. Okay, here we go. No, that isn't quite it. Okay, so we're going to I don't know. Yeah, I don't know if there's a sorting to these or not. I guess we'll find out. And let's convert them back. Loops equals polys to loops, and we'll sort them sort left to right. So sorted loops key equals np.min of And if we view these, oops, 2D, we should see this sorted and let's see here. Oh, I've gotta turn the original design off. Yep, and this is exactly what we wanted to see. So the first loop is blue and the second loop is green. By convention, we go left to right on the ship. So, okay, so now what we're gonna do is we are going to thicken these out using the same function where we triangulate it out. So rads. And I think we can stick with reactor inset for now. And actually here, to make this simpler, yeah, we can actually do the same thing. So we can actually just take one. So we can take rad rib equals loops 0. Inset it. Inset. And then triangulate. And I'm sure I've got a constant for the rad. Damn, this 0.2 would have been the thickness. I'm pretty sure. 2 times 2. And then we're going to do the same thing here with the vertex colors and then mirroring. So what I'm thinking is I'd like to have it like the hottest part be on the inside and then sort of fade out towards the outside. So we should have the zeros part be on the part that's greater than negative 0.5 or yeah, just say greater than negative 1 and this on the part that's less than negative 1. I'm not doing that anymore. This is like a vertex color that's shader input, not the actual irradiated color. Mirror it in X, and then this will be the same thing. And let's actually just... Actually, yeah, we don't need the... We won't need the translations here. I was going to say we could reuse this whole thing, but not quite. And rad and rad flipped. And here the translation is going to be the rear of the reactor in Y, which is going to be negative reactor thickness, I think. And there's not going to be another offset right now, but we'll fix that in a second. So it's going to be Vy of minus reactor thick divided by 2. And I'm just going to add a note here so I don't forget that we have to adjust the okay, this looks right, except that we didn't inset, which makes sense because we didn't use this. Yep, okay. Now, I don't like the look of having the exact same inset, so let's try doubling it. And our vertex colors are not working at all. Oh yeah, because this needs to be 0. So the ones where x is greater than -1, oh, I've got this flipped around, and this also needs to be -1. Let's see, is that right? So where it's greater than -1, it should be 1. Where it's less than -1, it should be 0. Yes, okay. That is exactly what I asked for, but this isn't the gradient that we want. Okay, what let's do is, this is kind of fun. This is kind of like fun low poly modeling stuff here. Let's see if we introduce another point here. If that will do what we want when we triangulate. So if we look at this rib, see, coming back from Shapely, this is a nice sorted order counterclockwise that I think we can count on. So what if we just insert another point here? I think that will do it. So let's actually plot this here, and then rib. I just gotta look up how to insert. Insert. Okay. Top insert. So we want to insert at position 1, basically just the point 0. Insert. Okay, what's going on here? Something isn't the shape that I think it is. Oh. Yeah. Okay, so now the hope is when we triangulate, this will end up... Jeez. Okay. 0, 1, 2, 3, 4, 5, 6. Wow. What happened? That's surprising that that is failing on some kind of like, evidently it's failing on like a collinear. That's funny. Well, easy way around this is we can just kind of fudge this thing like this, and instead of this, it'll be let's see if this does the trick. Oh, got those flipped around. All right, so now this is better. And this is basically I think this triangulation will be okay. We just need to be a little bit more subtle with the vertex colors. So it's 1 and 3. It's 1. Okay. LastWiz4590 says hello. Hello, how's it going? So what we're just doing here is we're trying to... Yeah, there we go. That's what I wanted, right? So we have 1 here, and then we have 0.5 here, and then we have 0 here. So we get this kind of nice fade out. LastWiz4590 says, just wanted to tell you I'm amazed. Oh, thank you. That's very, very kind of you. Let's, and actually, I think we can make this a little bit more... Yeah, this is kind of what I was picturing. Okay, let's take a look and see how this looks in the actual final ship with the right colors. Okay, so LastWiz4590 says, I'm actually just started learning Python. Nice. So Python is my favorite programming language. It's been my bread and butter for many years, and I really enjoy working with Python. So I wanted to develop a game in it and do some cool stuff with 3D, so that's what we're doing here. Okay, so actually let's get rid of these plots and various things. Prints. We can regenerate things. Okay, Legion Astarte says, I'm just learning Python right now, actually learning classes. Okay, cool. So one thing that you might see in my code is that I actually don't use a lot of, when you say classes, I'm assuming you mean like object-oriented programming classes. if that's what you're talking about, something that you'll see in my code is I actually don't use a lot of object-oriented programming. Okay, Legionus Astarte says I'm doing it on step trace. If you didn't hear them, okay. I haven't heard of that. Is it like a online courses or something? So let's see. Did we do it? Oh yeah. Look at that. How cool is that? All right. So that is exactly what we wanted. Yeah. Doug Weiss says that's great. Yeah. It's fun. It's fun, like you picture this stuff in your head, and then it's fun to make it happen, even if it's kind of simple, you know? Like this is not, there's not anything super complicated about this, but it's neat to see it come to life. I'm just trying to think if there's a quick way to get this thing into the game, like actually in a scenario, without any kind of complicated behavior trees or things, or if there's other stuff that we want to do first. Let's see here. Did I have other to-dos for this? I forget what I was saying at the beginning when we started. I know I wanted to do this. I know I was talking about livery. Okay, so LastWiz4590 asks, what coding program are you using? Do you mean what IDE I'm using to write the code in? This is, if that's what you're asking, this is PyCharm. A lot of people nowadays use VS Code. I really like PyCharm. If you've heard of IntelliJ, they have a set of IDEs, IntelliJ for Java and CLion for C++. I really like PyCharm. I use different IDEs for work as well, but PyCharm will kind of always be my favorite. Let's just take a look at this quick. Did I want to do anything else here? We were talking about getting rid of the hard points, maybe moving sensors, adding windows. Oh, I know what I was talking about. I was talking about adding some glowy bits to the drive. That's what I should work on next, and that actually will be pretty straightforward too. So let's do that. And I think the way the ship viewer is set up, it's set up to have those drives glowing by default. So we should see them right away if we get things set up like right. So that's a good task. Interesting. Okay, so P2D circle. Let me just check how I'm doing this in some other ships. If I'm cutting things or if I'm... Oh, look at this. I have a nice function for doing it. Okay, so last was 4590 says, so I'm sorry, but I'm trying to understand your project. Is it a game or model preview? So it's both. The project is a retro space combat game. It's just a hobby project that's been under development for a while. And what we're doing today specifically is we're building ship models, and the ship models for the game are actually constructed using Python code. So the game is written in Python. The ship models themselves are actually created with Python code. So we're just running the ship viewer to look at the ships that we're building in the game engine. I can just show you what the game engine, what the game itself looks like. This is just a little preview of the, whoops. This is a little preview of a sort of instant action mode, and yeah, the game kind of looks like this. So this is just like a quick combat scenario, and let's see here. It's got Newtonian physics, sort of a more realistic style of combat, and I'm kind of recalibrating some physics, so things look a little bit spinny and bouncy right now. But yeah, a lot of ships. Ships with lots of different parts and components, kind of like classic 90s space combat simulators. Let me just see here. Show another little test scenario quick here. Lots of interesting components, heat management, AI and behaviors, kind of geared towards the goal of making cool space combat animations and things like that in sort of a semi-realistic way, at least to the level of realism that I'm interested in. So yeah, what we're doing today is just building and making some tweaks to one of the ship models. Does that answer your question about what the project is? It's kind of a unique thing, but it's a fun project. And then another aspect of it is that there's the game, which is sort of like a retro styled graphics, but then I also have versions of these ships that are done in a much higher detail, more realistic style, also generated with Python code. And if you look on my channel, you can find some live streams where if you see if I'm doing Blender stuff, that's the more realistic version of these things. So the idea is, like, I can develop these ship designs and then I can use them in different ways. I can use them in the game, make animations, do cool Blender renders, different things. I'm not clicking around modeling. I'm kind of building out the designs with code, and then I can reuse them in different ways. Cool. Last was 4590 says, again, I'm amazed. Yes, it does. Thank you. Okay, great. I'm still trying to figure out the best way to talk about what exactly this project is, because it's definitely unique. And I always feel like I've been working on this for a few years. So I always feel like, oh, I'm just on the verge of really crossing a line with it. But it's, it's like anything else. Things always are more complicated than you imagine, taking things to the next level. I had a lot of this kind of stuff prototyped out in the first year that I was working on this, but it took a few years to get to the next level. All right. Okay, nice. So I do actually have. I just have drive glow arcs function that I think we can use. Let's see here. Radius, thickness. Does this hard code? Oh, this is just the vertex colors. Oh yeah, there's the actual thing. Okay, cool. Okay. Last was 4590 says, well, this is my first year learning. I just started last week. Hope I can learn. Yeah, you can learn. It's never too late to learn. And there's never been a better time to learn how to program. There's so many free tools and resources. I personally wouldn't recommend just learning by having AI do everything for you, but AI is a great tool for like asking questions, giving it code, asking what it does, asking it to explain things in a way that you'd like to understand. There's so many great tools. And we'll make these things constants, but for now, we'll just let's see here. For the hand, what is this? 64. And yeah, okay, so interesting. So I don't actually have these in separate pieces right now, but that's okay. We will. Why does this need to know the radius? Ah, okay, yeah. Why does this need to know the radius? Oh, it's just for checking whether it's on the inside or outside. That makes sense. I'm just gonna add a little note to that. Actually, let's just do this. Okay, now we need to make the parts for these. So parts glow equals actually there's just one, right? So, and to do for now there's just one. And let's see, for Hammond, I think we just call it glow. Oh, I do actually have front and back. Let's just steal this. So, and we don't have two engines, we just have one. So, drive, school mesh, facing. This should be drive thick. Let's see here, drive thick. Drive 1 divided by 2. Yeah, so drive len divided by 2. Marking is true, glow is true. Okay. And then we're just going to add glow in here. Glow. And let's see here. Just in this module we're using parts as a prefix. Now, vertex colors is glow VC, so we should see these show up in our thing. Now, I'm expecting that maybe we don't have quite the right thickness. We might have to have different thicknesses for front and rear. Yeah, it's too thick. Now, let's see here. This is interesting. There's like multiple things that are sort of wrong about this. And let's try to figure out what they are. So, it looks like we're offset. It looks like... Okay, so... I think for starters, let's just do this. So here we're only making the drive thinner. So really, let's see here. Drive radius, stick. I think this is what we want to use for the radius, right? No, I think we, yeah, let's see here. Yeah, the white objects around the ship are representing the glow. So it's these, I'll show you here. It's these pieces here, right? And they're supposed to be kind of like matching up with this. So like, we'll just take a look at another one of these ships where it's working properly. Like on the Hammond here. we should be able to see it pretty clearly. And there's a little bit of Z fighting here because because they're on the same plane. But now the thing that's really interesting to me here is why are these aligned the way they are? Because here I've got is it just the count? Because it's a multiple of 3. Drive thick. Okay. Let's just do this and I don't feel like actually figuring out what's going on, so we're just gonna iterate on it a little bit. Yeah. Yeah, exactly. I have to offset the radius a little bit. Yeah, see, this is looking more right. Now, what's going on with... I'm surprised that the... I'm surprised that the angle of these things does not match up with the angle offset. Do I have some kind of angle offset? Start angles offset is angle frac divided by 2. That's odd. Gosh. There's like an angle offset thing going on here too, which I don't quite get. Like, why is this not matching up? What's going on here? Glow, translation, rotation, and here, let's see, I think it's probably the same number of subs too. It's 12, right? Try subs is 12. Yeah, so why don't these match up? Yeah, what gives? Three, 1, 2, 3. Yeah, they don't. They sort of look like they match at first glance, but you see, like at the top here, there's a flat part. Donish X3 says, I'm back, but can you give me inspiration to code? Yeah, I mean, you should think about a project that you're excited about, and that's what you should do. I think you have to want to do something and want to build something, and that, like, wanting to build something is going to be a better inspiration than wanting to learn to code, right? Does that make sense? This is interesting. Let me just turn this off for a second. I mean, this isn't going to be... Maybe that's just what I have to do here. Oh, I know what it is. Yeah, it's just this count. This works for count 3, but not count 4. Yeah. Maybe. That's some good good advice there. Last was like it's the sense of accomplishment is really fun, and knowing the details of your project is really fun too. I've talked about this in other streams, but I use AI a lot in my work, in my day job, and it is you can do a lot, and you can do things very quickly with AI, but it's sometimes not so much fun to not understand, you know, like when you write code yourself, part of the process of writing code is like understanding what you're writing at a very deep level. Like even like what I'm working on right now, this is kind of like an annoying little issue, but it is fun at the end of the day to have worked through this. Okay, now this is actually looking like pretty close to what I want. Okay. Okay, cool. So now we just need to offset it correctly. So the we're going in between. Let's make this consistent. We're going in between this radius and this radius. So let's actually bring these out into some variables so we can control this, right? Yeah, you're right, Les, was it's a little bit off. So we're trying to fix that. let's do the front. Let's see, is this right? Yep. That's just this. Donish X3 asks, what should I do to learn more code C++? I mean, again, I think you just gotta choose a project that you want to do and say, I'm going to write this in C++. And then, you know, if there are certain things that you want to learn, you know, choose a project that kind of tries to touch those things. But I think it has to be something that you sort of want to do separate from the idea of learning C++. I think it's very hard to learn a programming language when you don't have a project that you want to build, right? Okay. So there it should be lined up in the middle on both sides now. Okay, cool. Let's generate this and see how it looks in the viewer. Ooh, this is a good one. It's called Nightscapes. Cool. The little chorus in this song is great. Nice one. Okay. So I think actually we can jump to it right away like this. Nope. That. Perfect. All right. Oh, and the glow is not there because it's not in the YAML file, so we just got to add that. Now, I reworked how this stuff worked a while back, I think, and I made it better. So hopefully we're not fighting the YAML. This is just game data that basically assembles the parts here, so we've got to exclude the glow from this and then add it back in like this. Under children. I can never remember how you're supposed to indent YAML. It just does not seem logical to me. There we go. Okay. So that's correct, but it's offset wrong, which this is an issue with this. Parent is the drive. Oh, I know what I've got to do. Yeah, I've got to just all the coordinates get flattened out here, so I've got to put all of this under children. Okay, good. We just need the what happened to them? Yeah, I just lost the material somehow. Oh, I know why. That's in livery. Mods map. Shuttle mods map. Shuttle mods map. And okay, nice. Last Wiz 4590 says, good luck, bro. I really enjoyed watching. My class starts in 5. Good thumbs up and sub. Wish you the best. Thank you so much. It's good chatting with you. Hope to see you again next time. I stream a couple times a week, usually, if I can. And yeah, it'd be great to see you again. So yeah, thanks again for hanging out. Okay, so this looks just about perfect, except I think I want to try a couple things. So I want to actually do all completely separate segments. So I want nice. Donish X3 says I'm watching this while coding. Nice. I like to watch or listen to live streams while I code a lot. So hope that this inspires everybody to work on their own creative projects. gonna do this. Let's do the full 12 here. And make this smaller. Now see, there we have that off by... Okay, we're just gonna solve this like this. There's still something that's not quite right about the thickness, but I think this is a good 80-20 start. And what we just want to do is we want to exclude those inside ones. So let's see here. So let's whoops. Yep, so what we're gonna do is we're gonna separate this into individual meshes and angle sort the centroids and then toss out certain indices. So so meshes equals graph dot, let's see here. Graph dot split components. Look at this sort. Where was that? That is in I've got this functionality that does exactly what I want to do, where I'm like I can sort by angle. Centroids equals C dot P dot mean. Radial sort. That's it. This is another good one. It's called data. A lot of good views tonight on this live stream. Trying to figure out patterns. My data's a little too sparse to do that, but let's see, merge dot radial sort. What is this radial sort mesh? There it is. Find radial position sorting. And to check that we've done this right, we can extract the border loops, right? So oh, nice. Donish is making some progress with his coding projects. Nice. Okay. Let's see here. Let's see here. Boundary X. What am I doing wrong here? Oh, and radial position sorting. Oh, this is probably supposed to be an array like this. Maybe. Let's see here. Oh, jeez. Okay. Shapes. Okay. I think blue is first, and this makes sense. Blue, we're getting that. So I think we're sorting these properly. Okay, nice. Experimenter I8V says, "Yo man, how's it going? I'm new here." Nice. Well, welcome. We're just actually pretty close to wrapping up for the night, I think. So we're doing some 3D modeling with Python. And just kind of doing some 3D math. This should work for its radius thickness, yeah. Just doing some final details on a ship that we're working on. Oh, no. Oh, that's too bad. So experimenter I8V says, "I got laid off last month from a full stack dev position. Now I'm not able to land a job." Yeah, that's rough. I got laid off a couple years ago from a position that I was at, and it took me a good chunk of time to find a new job. And I really love my job. I've been there a couple of years now. It's no fun being laid off, but I think actually wasn't laid off for a super long time. It was maybe like a month before I found a new job. But I think if I was laid off again, I would try to really put the time into working on some projects to have some cool things to show as I'm looking for a new job. I think like I interview people, and I've been part of the search for new hires in all the jobs that I've been in, pretty much, and it really helps a lot. And you can stand out if you have some neat projects you can show, aside from just kind of talking about things in the abstract on your resume. So, and I have a few projects that I've done that I've kind of credited with being able to get me jobs. This project actually, I think, helped me get my current job. So experimenter I8V says, "I'm not that experienced, bro. I started my career a year ago. This is my first job." Yeah, and unfortunately, I think it's just the reality of our field that even if you're not experienced, you kind of need to have projects. When I say projects, I don't mean like big professional projects. I mean even just sort of small, interesting things that you worked on that show that you have relevant, interesting experience. Like, I got my first job as an intern because of research experience that I did during school. So even just like sort of a very much part-time research project that I did during undergrad helped me get that job. And it's kind of a bummer. I know a lot of people are like, "Oh, I should just be able to, put my resume out there and get hired." But I think it's just kind of a fact of life that projects are a part of getting a job. But again, like, there's never been a better time to be working on projects, building cool stuff. I mean, everything is free. The resources are free. You have AI coding to help you out. I mean, obviously you don't want to use that as a crutch or not be able to explain what you did, but I mean, you could just go to town now and make some cool projects to show and be able to talk about. That's just my my experience and advice, but yeah, it's rough, but I think on the bright side, again, like the resources that you have access to now, I think even like for me, thinking back to when I got laid off and was looking for a new job a couple of years ago, like there's so many more resources now, even just with AI, to be able to um to be able to build things that you could show and talk about. Yeah. So experimenter I8V says, "Are you doing 3D modeling in Python?" Yes, that is what I'm doing. So, okay. So let's see here. Just putting some final touches on this low poly ship that I'm building here. Not in. So let's see. We don't want the first one. There's 12, right? 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. We don't want 5, 6. Yeah. And little mesh. That's cat meshes. And I think this should still work. So experimenter I8V, how long have you been coding? Answer if you can. Well, I have been... Oh, cat. I've been coding for about 25 years. So I've been coding since I was a little kid. Professionally, in my career as a software engineer, I've been coding for about 14 or 15 years. Yep, there we go. So okay, so basically to review what we did here, yeah, I'm close to 40, so I've been coding for a while. And I'm not a genius, but you do learn a lot on the job, for sure. And I've been really fortunate in my work to be able to do a lot of different things and learn from a lot of really smart people in a lot of different domains. So, okay, so just to be clear, just to review what we did here. So I'm gonna just plot some things again here. So what we did here is we generated this circular array of these segment meshes. We disassembled it, sorted them by centroid, and sorted them in order around the circle so we knew which ones to toss. And we tossed this one, this one, this one, and this one, and we know that ordering is going to be consistent, isn't going to be non-deterministic because we sorted them. And then we end up with those. And now when we run our ship viewer, oh nice, Donish X3 says, sorry for the spam, but the project worked. Yeah, so experimenter I8V says half of life. Yeah, like it programming is something that, you know, I really like, and it's something that I knew from when I was pretty young that I wanted to do for a career, and I've been really fortunate to be able to do it. And I think part of being good at it is, you know, that I've been doing it for a while and I've spent a lot of time doing it. So, all right, yeah. So there's our low poly shuttle. We've got glow pieces now. Actually, here let's just do this. So, let's just use up that original flag again. So let's see, parts global. Let's just look at our bench here. So, yep. So, our new design versus our original design. Yeah. So, a couple important tweaks were made. This is kind of fun. Some kind of fun geometric programming here. It's getting kind of late, so I think I'm going to hit the sack for the night. And I'm going to think more about how we're going to integrate this into the game or scenarios, because eventually we want this to be something like the like sort of a target, or you know, something that you might have to scan or interact with in order to win. And let's just update this here. I think this stuff is still a little bit up in the air, and this is the shuttle now. And yeah, we don't have an actual correct name for it yet, but yeah, and there's a lot of missing stuff yet here, but my detail, yeah, okay, cool. Well, this was a productive little time, and had a few people hang out. Thanks to Donish, Experimenter IV, Legion Astartes, last was 4590, and Doug Wise for hanging out. As always, it's fun to just be able to go live and work on this stuff and chat with people and hang out. I hope everybody else has a good night, and I hope that you're inspired to work on your own creative projects too. So have a good night.